Students, in this video and next few videos, we will solve some problems of parabola. First problem is find the equation of parabola whose vertex is 0, 0 and focus is minus 2, comma 0. Two things we have to keep in our mind when we are solving the problem on parabola. Number one, we have to identify the parabola is in standard form or in general form. So if parabola is in standard form means vertex of parabola will be origin, focus will lie on x-axis or on y-axis, directrix will be parallel to y-axis or x-axis, and axis of parabola will be x-axis or y-axis. So these are the conditions for parabola being in standard form. And if parabola is in general form, then focus will neither lie on x-axis nor on y-axis. Vertex will not be on origin. Axis of parabola will not be x-axis or y-axis. Directrix will not be parallel to y-axis or parallel to x-axis. So first we will plot these points. Vertex 0, 0 and focus minus 2, 0. Draw a coordinate system. X-axis, y-axis, origin. Vertex is 0, 0. So 0, 0 is origin. Vertex is at origin. And focus minus 2, comma 0. Minus 2, comma 0 point will lie on x-axis in the left of origin. Suppose here. Minus 2, comma 0 is point on x-axis in the left of origin. And one point we have mentioned in properties of parabola. That is a very important point in solving problem on parabola. And point is that the mouth of parabola opens from vertex to focus. Vertex is here, focus is here. So mouth of parabola will open from vertex to focus means parabola will be in this shape. Coordinates of vertex are 0, 0 and minus 2, comma 0. So this parabola is in standard form because vertex is origin and focus is lying on x-axis. So this line passing through vertex and focus is axis of parabola, which is x-axis. So the directrix of this parabola will be perpendicular to x-axis or parallel to y-axis. So this line is directrix. And one point we mentioned in properties of parabola is that the distance from vertex to focus and distance from vertex to directrix be same. So if this distance is 2 unit, then this distance is 2 unit. This is minus 2 because this point is lying in the left of origin and this line is lying in the right of origin. So this distance will be taken as positive. So x equals to plus 2 or x minus 2 equals to 0 is equation of directrix. This parabola, since this parabola is in standard form, so one thing we have to identify the type of parabola. This is a which type? 4 standard forms of parabola we have studied, and this is a second type of parabola. And then identify the value of a, which is here 2. And substitute the value of a in appropriate form of parabola. And appropriate form of this kind of parabola is y square equals to minus 4ax. And here substitute the value of a, which is a is here 2. So parabola is y square equals to minus 4 into 2x or minus 8x. Y square equals to minus 8x. And if suppose we are unable to find the appropriate form of parabola, then write the equation of directrix and coordinates of focus are known, and then use the definition of parabola. PS upon PM is equal to 1 or PS equals to PM. This ratio be eccentricity, and eccentricity in case of parabola always be 1. So this is 1, ps equals to pm. Ps is distance from variable point p whose coordinates always taken as xy, and pm is this distance. So if we are unable to identify the appropriate form of parabola, then we will use this definition of parabola, and in this definition we are required two things. Number one, coordinates of focus, and second thing, the equation of directives, and substitute the values in this form. That is ps is this distance, this we use distance formula to find it, and pm the perpendicular distance from point p to directrix, and substitute in this and solve it, we will get the same equation of parabola. So this is the solution of this question. Thank you.